K-means clustering algorithm is an unsupervised machine learning algorithm which groups the unlabeled data sets into the different clusters, right? Here, K defines the number of predefined clusters, such as, let's say here there are 3 clusters. So K equals to 3, cluster 1, 2, and cluster 3. Now there will be 3 clusters here because K is equals to 3. If there are more number of clusters, K will be 4. In that particular case, we'll have 4 number of clusters. It's an alternative algorithm. It's an iterative algorithm that divides the unlabeled data sets into K different clusters in such a way so that each data set belongs to only one particular group that has the similar properties. Here you can see my cluster number 1. It has all the data points which are similar to each other. Here it is cluster number 2, which includes all the data points which have the similarities. Here it is cluster number 3, which have the similarities, and it allows us to cluster the data points into different groups, and which is a convenient way to discover the categories of the groups in the unlabeled data sets without the need of any training. So here you can see it's like unlabeled data set. We do not know the features, how they behave, the characteristics we do not know. Then these algorithm, k-means clustering algorithm, which identifies the pattern that these are the characteristics which are similar to each other. These are the characteristics which are similar to each other, and then so on. It will try to frame the cluster, including those points within that particular cluster, and so on. It will try to frame a cluster of those points within that particular cluster. It is also called a centroid based algorithm, where each cluster is associated with a centroid, and the main aim of this algorithm is to minimize the sum of the distances between the data points and their corresponding clusters. This algorithm generally takes unlabeled data sets as an input, and it will divide the data sets into k number of clusters, and then it keep repeating it will keep repeating the process until it does not find the best particular clusters, the best particular number of clusters. So k should be here is like a predefined factor in this particular algorithm. In this particular algorithm, k should be a predefined factor, and then k-means clustering definitely is mainly performs 2 tasks, such as, let's say, first one is to determine the best value of k, which are nothing but the number of center points, right? Best number of center points, k equals to, let's say, 2 here. So in that particular case, there will be 2 clusters framed, right? Or you can say 2 centroids. Using the iterative process, it has to run multiple iterations and understand this would be the best value of k, and it will assign each data point to its closest center k. So for an example, if I take a center here, I have to do the iteration and then move the centroid also. But if let's say assume I selected a center here, then what are the closest points to them? They'll be allocated here. They'll be definitely associated with this particular center, and then it will frame the cluster. Hence, each cluster has data points with some sort of commonalities, and it is away from the different clusters. So based on, let's say, my some sort of characteristics or similarities, I'm going to put them together jointly, that these are functioning similarly. The major steps how the k-means algorithm works. Step number 1 2 is select the number k to decide the number of clusters. So in this particular case, you can see there are 3 clusters. So I have to select k equals to 3 here. K equals to 3 here. So 3 number of clusters will be there. Step number 2, select random k points or centroids, because I do not know what's the optimal value of k yet. So I'm going to take some sort of random random k points or centroids. So let's say I have selected 2 here, or maybe 3 here, or 4 here. Then later I can modify it. It can be other form of the input data sets. Also, you can give it through the input data sets also, that randomly, let's say, start from k equals to 5 and then find the optimal value of k at your own. That is also possible. Assign each data point to the closest centroid. Start placing the points nearby that particular centroid, which will form the predefined k clusters, right? So it will frame some sort of k number of clusters. After that, calculate the variance and place a new centroid of each cluster. We got to keep moving my centroid, such as, let's say, initially if I set up a centroid here or here. Then I keep measuring and then I keep moving my centroid, right? Keep moving my centroid, optimizing that particular distance. That we will see one by one in each step. So step number four was calculate the variance and place a new centroid for each cluster by optimizing the distance, by observing the distance. Right? Repeat the third step, which means it will reassign each data point to a new centroid, new closest centroid for each cluster. So when we move the centroid, right? So data points will also be allocated here, and then this line will also shift, and then it will create different clusters. So let's say I moved my centroid here. So look at this, the position of the separation line is changed when I moved my centroid by checking the variance of the distance, right? So using that, we keep assigning or keep reassigning the points to them again. So if any after that, yeah, step number 6 is if any reassignment occurs, then we gonna go to the step number 4 again and calculate the variance and place the new centroid for each cluster again. Then again repeat step number 5. Then again you check, keep circling around between step number 4, 5, and 6. And once, let's say, there is no reassignment is happening after multiple iterations, that means our model is ready, and then we have to terminate here. And then we get outcome 3. Here we can see we got 3 clusters in that particular outcome, and we can say that this is my optimal number of clusters. And here you can see all of them are similar with each other. How it works, let's take k equals to 2 initially. I'm not taking k equals to 2 initially for this particular data set, right? So k equals to 2, if I take to identify the data set and put them into different clusters, it means like here we will try to group the data sets into two different clusters. So you can see this is kind of a boundary, and you can see major strength here, major strength here, right? This points can be either the points from the data sets or any other points also, Now what we are going to do is we are going to assign each data point of the cluster plot to the closest k point or centroid, So you can see this is my centroid, right? So I'm going to keep assigning my data points which are closer by to that centroid, and then we are going to draw the median between both the centroids. So here you can see the points left hand side of the line which are near to the k1. Remember, we do not know the optimal centroid position yet, so we have started some initial position, and then we are going to do the multiple iterations. Now you can see these points you can see left hand side of the lines, they are nearby this blue centroid. And these points are they are nearby the yellow centroids, right? Then they are nearby the yellow centroids. Next step, uh, we have to find out the closest cluster. So what we will do, we will repeat the process by choosing a new centroid. So these 2 points were far located, right? So very away. So you can see it's not even a nearby located. So what we are going to do is we're going to move it a bit or shift it a bit nearby to this. So the average distance is like optimized, or you can say minimal across all the points. So here I'll move a bit here, and this I can move it a bit here. Right. So I'm going to I moved my you can see I moved my blue centroid here, and then yellow centroid I'm going to move it here. And then this is kind of a new centroid position, right? New centroid position. And now to choose the new centroid, we will compute the center of gravity of each centroids, and then we will find out the new centroids as below. And next, after that, what we are going to do is we will reassign each data point to the new centroid. Now, once we have a new centroid, we will reassign, and we will see is there any deviation in the data points distance from the centroid. Right. For this, we will repeat the same process of finding the median line again and again, and then we'll keep reassigning them. Now we can see one yellow point is on the left hand side. Here you can see after reassignment and other things, you can see one yellow point is at the left hand side, and the two blue points are at the right hand side of the line. Like this is my median line. You can see that two blue points have crossed over and one yellow point has crossed over here. So these 3 points will be reassigned to the new centroids. Right. What am I going to do is I'm going to put this yellow dot associate with this blue centroid, and I'm going to put this blue dots associated with the yellow centroid because they have the similar characteristics nearby this, similar characteristics nearby that. As the reassignment has taken place, so we will go again back to the step number 4 and find the new centroids for k points, right? Now again I will see this centroid is at a distance. This centroid is at a distance. So what am I going to do is I'm going to go to step number 4, what we have just discussed. Step number 4 was, let's see, let's go to the step number 4. Calculate the variance and place a new centroid of each cluster. Calculate the variance and place a new centroid of each cluster. So what am I going to do? I'm going to calculate the variance, and then I'm going to move or shift a bit this centroid at a center. And then you can see I'm going to move this yellow a bit here, this side, because that's how the variance changes. The distance is like should be minimal across all the points, and then I move it. Once I move it, we will repeat the process by finding the center of gravity. That we have covered. So that we have covered. So now you can see once I have moved it, then I'm going to do the reassignment again. Then I'm going to do the reassignment again. As we got new centroids, so again we will draw a median line. So you can see now based on these two new centroids, you can put a median line here rather than this way, right? Rather than this way, I can put a median line here. I can put a median line here. I can put a median line here, and I can reallocate the points also, such as let's say these 2 points are nearby this particular blue region. So rather than keeping them yellow, I can merge them merge them with blue and say that okay, similar characteristics nearby the blue centroid, right? And then I can put my line here. So it'll give me median line here. So it'll give me a clear cut separation. It will give me a clear cut separation. You can see none of the points are crossing over again. So as we got new centroids, we will draw the median line again and reassign the data points. So those two yellow points were associated with blue. So I converted them into blue here, and then I am putting that here, and I am putting that here along with this. Okay, along with that. And you can see after that we can see that there are no dissimilar data points left. There are no dissimilar data points left on either of the side of the line, right? Which means our model is framed well, is working nicely. You can see that clear cut separation. I received a clear cut separation. As our model is ready, so we can now remove the assumed centroids as we don't need them anymore, and two final clusters are as shown in the image, right? So these two are my final centroids. We don't need them anymore, right? So it's like clear cut, and we can remove the median line in order to show the centroid, in order to show that, because those are the inherent steps to reach this two clusters. So here I can see this 2 k equals to 2. I frame my two clusters. So that's how the algorithm works. That's how the algorithms work here. Algorithm works here in identifying the number of clusters and segregate the data points into the clusters. The question comes, how to choose the value of k, which is k number of clusters in k-means clustering. That is the important one, because we do not know how to do that. So the performance of the k-means clustering algorithm, it depends upon the highly efficient clusters that it forms, but choosing the optimal number of clusters, which is k here, is a difficult task. Because we do not know, and we have to choose this. So that would be some sort of methods. There are few methods, such as, let's say, there are different ways to find out the optimal number of clusters, which is k here, which we are discussing. And the most appropriate method what people use here is to find out the k number k here, number of clusters, like an elbow method. Using this particular method, we try to identify what's the optimal value of k, which is nothing but the minimal number of clusters. The elbow method is one of the most popular method to find out the value of k here. It generally uses the concept of WCSS. That means what? Within clusters sum of squares. Which defines the total variation within a cluster. tell you what's the total variation within a cluster, and it employs the following formula. It employs the following formula, WCSS, how it measured, like summation pi in cluster 1 into distance pi C1's whole square plus so on. This is my equation, where here summation pi in clusters 1 distance pi c1 square indicates that it is a sum of the square of the distances between each data point and its centroid within a cluster 1, and similarly other two terms can be explained, right? So using this particular method, elbow method, employing WCSS elbow method, will try to identify the optimal number of clusters. To measure the distance between the data points and centroids, we can use any method, other method also, like such as any method to measure the distance point. We can use like such as method as like Euclidean distance method. That is also a good method, where you identify the Euclidean distance between the data point and centroid, and then go on with it. Like to find the optimal value of clusters, uh, this method is for executing the following steps. So generally what it does, it executes the k-means clustering on a given data set for different values of k. Let's say typical range could be 1 to 10 based on our inputs. For each value of k, it will calculate WCSS value. It will calculate WCSS value, and then it will plot the curve between calculated WCSS values and calculate the it will plot the curve between WCSS value, which is on y-axis here, and the number of clusters k, So for each value, let's say k equals to 1, it will compute WCSS. K equals to 2, it will compute WCSS. 3, we got WCSS value. So on, it will try to compute WCSS. WCSS, as we said, is nothing but within cluster sum of squares using this particular equation, which includes the distances here. Again, you can see that. Now, it is the sum of the square of the distances between each data point and its centroid of that particular cluster, right? So it will compute that, and then it will try to identify that which value of k reduces the WCSS value. So here you can say k equals to 1, WCSS is very high, so which is unlikely that we select k equals to 1. Then we see k equals to 2, WSS value came drastically down. Then further k3 drastically down, and then so on. You can see the decrease is diminished. So either you can pick up k equals to 3, which is nothing but the optimal number of clusters. You can pick up k equals to 4 also, which is okay. But it will create more number of clusters and centroids, right? So here could be optimal based on the larger similarities. K equals to 3 could be an optimal value of k, considering that particular formula of WCSS. At the sharp point of the bend, you can see the sharp point of the bend here. You can see this point, or the point of the plot looks like an arm. Here you can see the bend or arm. That's why it is called an elbow method. And then that point is considered wherever the curve is taking a sharp turn, and then you can see that point is considered as the best value of k. That point is considered as a best value of k. Since the graph shows the sharp bend and it looks like an elbow, that's why this method is known as elbow method to find the optimal value of k for k-means clustering algorithm.